Now we're going to maybe clarify a little bit more about limits and also talk just a little bit about continuity. Fairly intuitive notion, but the mathematics of it, you got to be a little careful. Okay, so we have a function that I'm going to call f of x. And it's equal to x minus 3 over x squared minus 9, the function we just analyzed in the preceding. When x is not equal to 3, it's going to be equal to this function. You recall that when x is equal to 3, the denominator is 0, which makes this function undefined. We investigated the function, though, and found that we have a limit of 1/6 as x approaches 3. So we're going to define this function, f of x, to be 1/6 when x equals 3. So now we're going to complete this function with the value that the expression here approaches as x gets close to 3. We have g of x function. Okay, the g of x function is going to be defined the same when x is not equal to 3, but we're going to make it something else. And I just asked somebody to give me their favorite number. Somebody had 12 as their favorite number. Okay, so we let g of x be 12 when x equals 3. We can certainly make that definition. Now, there seems to be a lot better reason to let the value be 1/6 than to let the value be 12, but we can define the function with any value at x equals 3. Okay, so in the first case, what's the limit of f of x as x approaches 3? Well, as x approaches 3, you never even consider what happens when x is equal to 3. So the value of this function at x equals 3 is irrelevant to the limiting value as x approaches 3. Because as x approaches 3, it never is 3. So as x approaches 3 here, through values of x that are not equal to 3, because you can't approach 3 if one of your values is 3, you're at 3, not approaching. Okay? As x approaches 3, we know from what we've seen before that, first place, this expression is going to be the same as 1 over x plus 3, and as x gets close to 3, 1 over x plus 3 gets close to 1/6, which is, of course, the value at x equals 3. Okay. So we've established, again, we ignore what happens at x equals 3. We only look at what happens when x is not 3. And if x is not equal to 3, the limiting value is 1/6. So we can say then that the limit as x goes to 3 of this function is equal to the value f of 3, because f of 3 is defined to be 1/6. When x is 3, this function is 1/6. It's equal to its limiting value. So that fits the function. Now here's a picture of our function. I haven't labeled the y values, but we've gone from like 0.2 down to like 0.143 as x goes from 2 to 4. And we have this nice smooth curve, except at this one point where this x minus 3 over x squared minus 9 is not defined. Well, we just define it to be the value that'll fit right into this curve. In this case, this is our f of x function. F of 3 fits the curve, and f of x is continuous at x equals 3. Now, the g of x function, on the other hand, if we graph it, we have the same curve. Now, we don't have a value, the x equals 3 number does not lie on the curve. Okay, the x minus 3 over x squared minus 9 applies only if x isn't 3. And when x is 3, we haven't defined the value to be here. We've defined it to be way up here. And of course, on the scale of the graph, 12 would be much, much higher than this. But we've defined it to be somewhere other than here. So now the function doesn't look like what we'd say is continuous. This is nice continuous. You just keep going and you never jump or do anything. Here, you just keep going along the curve, but all of a sudden you got to be right up here, but then you got to be right down here immediately afterwards. So we're going to say the g of x is not continuous at x equals 3 because of this behavior, but the definition of continuity is simply this. Okay, the limit as x goes to 3 of g of x is still 1/6. Because, as before, we don't care what x is at x equals 3. The limit only depends on what happens close to x equals 3, and that limit is therefore 1/6. So, because, again, remember that this function is identical to 1 over x plus 3 whenever x is not equal to 3. Now we can say that the limit as x goes to 3 of g of x. Well, we can ask, is the limit as x goes to 3 of g of x equal to g of 3? No, because g of 3 is 12. G of 3 is not consistent with the trend of g of x. And I'll just add here that the limit as x goes to 3 of g of x, this is 1/6. And this is 12. So they're clearly not equal. And that's reflected in this behavior. Okay? The definition of continuity is that the limiting value of f of x at a point is equal to the value at the point. And you'll see more about that when we formally get into that section and when you read what your book is telling you about it.